Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, we will solve some more examples on temperature stresses. Let us start. Example number 2. Let us see what is given in this example. A steel rail 12.6 meter long is laid at 24 degrees Celsius. When these rails are laid, the temperature was 24. The maximum temperature expected is 44 degrees Celsius. In short, this is T1, this is T2. So this is rise in temperature. Determine 1. The minimum gap between two rails to be left so that no temperature stresses are developed. Now you have studied in your basic science in 8th or 9th, there is a gap between two rails. Why the gap is kept? Due to friction, temperature increases. So those rails may not move one over the other. Hence the gap is kept. What should be the gap? This is asked in this particular example. Second, the thermal stress developed in the rails if no expansion joint is provided. Means if no gap is provided. Take E is equal to 2 into 10 raised to 5 Newton per mm square and alpha is equal to 12 into 10 to the power minus 6 per degree Celsius. This is also the question which is asked in MSBT examination for 4 marks. Now, let us see what is given in this particular problem. Okay, so let us see the given things. The first one, L is given 12.6 meter. Initial temperature is given T1 24 degrees Celsius. Final temperature is given 44 degrees Celsius. Okay. Then E is given 2 into 10 to the power of 5 Newton per mm square as usual. And alpha is given thermal coefficient 12 into 10 to the power minus 6 per degree Celsius. Now what are the things required? What we want to find out? Gap. What should be the minimum gap to be left? Okay. So first thing we have to find out is gap. What gap should be kept in the rails so that those temperature stresses will be developed. And the second one, if no gap is there, what will be the thermal stress induced in the rail? This is what is asked in this particular problem. So let us see how to find out. Now, the first very important thing is what is change in temperature? T will be T2 minus T1. Value of T2 is 44. T1 is 24. So it will be 44 minus 24 equal to 20 degrees Celsius. Now, we are asked to find out the minimum gap between the two rails to be left so that no temperature should be developed. Now, due to this rise in temperature, the rails will expand. Now, how much gap should be kept? The gap should be kept so that the free expansion of the rail will be equal to that gap. So if you keep that gap, whenever there will be free expansion, the gap will be filled and no stresses will be induced. So I will say the gap to be kept in between two rails must be equal to free expansion of the rail. Free expansion. Of rails. Now, what is free expansion? Free expansion is alpha into T into L. Put the values. Alpha means 12 into 10 raised to minus 6 into T is 20 into L is 12.6 meters. Convert it in mm, 10 raised to 3, and if you calculate this, it comes out to be 3.024 mm. So this is the first answer. What minimum gap is to be left? So this we have solved. Now we have to go for second. If no gap is kept, what will be the thermal stress induced? We know that thermal stress how do we denote thermal stress? Thermal stress is denoted by sigma T is equal to alpha into T into E. Put down the values. Therefore, thermal stress sigma T is equal to alpha means 12 into 10 to the power minus 6 into T is 20 into E is 2 into 10 raised to 5. If you calculate this thing on calculator, you will get the value as 48 MPa or Newton per mm square, and as this is rise in temperature, its nature will be compressive. C means compressive. Do you understand? So this is the answer of second thing which is asked in the problem, and in this manner this second problem is also over. Let us solve the third example. A steel rod 20 mm in diameter and 1.2 meter long is heated through 120 degrees Celsius. At the same time, it is pulled by a force P. If the total extension of the rod is 3 mm, calculate the value of P. Take alpha is equal to 12 into 10 raised to minus 6 per degree Celsius and E is equal to 200 GPa. This particular problem is asked in the BTE examination. Now let us first list out the things given. So what are the things given? Diameter of the rod is given, say 5. 20 mm. Then the length is given 1.2 meter. It is heated through. Here you have to keep in mind that heated through means change in temperature is directly given. When two temperatures are given, you have to take it as T1 minus T2 or T2 minus T1. Here only one temperature is given, that is the rise in temperature is given, that is directly T1 minus T2 is given, which is 120 degrees Celsius. At the same time, a pull P is applied on the rod, and the total extension of the rod is given as 3 mm. Value of thermal coefficient is given 12 into 10 to the power minus 6 per degree Celsius, and E is also given, that is 200 GPa. 200 GPa means 200 kilonewton per mm square, means it will be 2 into 10 raised to 5 Newton per mm square. So these are the things given in this problem. What is required? What we want to find out? We want to find out the value of pull P applied on the bar. Okay? So let us start the problem. Here, the total extension of 3 mm given in the rod is due to two reasons. One is due to heating the rod, and second is due to pull. Okay? So we will say that the total extension is equal to extension due to heating plus extension due to pull. Pull P. Okay? So let us substitute the values. The total extension is given as 3 mm is equal to, what is the extension due to heating? It is alpha into T into L. And what is the extension due to P? We saw it in stress strain. Whenever pull is applied, extension is P into L upon AE. Now, let us substitute the values of alpha and T and L. What is alpha? Alpha is given as 12 into 10 raised to minus 6 into T is given as, directly change in temperature is given 120, and L is given as 1.2 meter, means it is 12008 mm. We have to convert it in mm. This is the extension due to heating of the rod plus P we want to find out. What is L? L is 1200 divided by, what is A? Circular rod, pi into 20 square upon 4, and E is 2 into 10 raised to 5. Now if you calculate it on scientific calculator, you will get the extension due to heating as 1.728 mm, and if you calculate the second term, you will get it as 1.91 into 10 raised to 5 10 raised to minus 5, this will be in numerator, P. If you deduct it from 3 and divide that value by this one, you will get the value of P as 601.92. It is the force, it is in Newton. If you divide this value by 1000, you will get the answer of P as 66.6 kilonewton. So this is the answer of this question. So if you apply the pull of 66.6 kilonewton, at the same time if you hit the bar through 120 degrees Celsius, the total extension you will get is 3 mm. Okay, therefore we have calculated the value of P. Let us go for the next problem. So let us see what is given in this problem. A steel rod of 50 mm diameter is held between two supports 10 meter apart at 150 degrees Celsius. The temperature falls to 50 degrees Celsius. Find the stress in the rod when the supports do not yield, means do not change their position, and second, yield by 10 mm. Value of E and value of alpha are given. Okay, so let us solve this problem. So let us first write down the things given. So what is given? "50 mm diameter rod, that is phi is equal to 50 mm. Held between two supports 10 meter apart," means the length of the rod is 10 meter. Initial temperature T1 is given as 150 degrees Celsius. The temperature fall in temperature, so temperature stress will be tensile in nature. T2 is given 50 degrees Celsius. E is given as usual 2.1 into 10 raised to 5 Newton per mm square. Then alpha is given 12 into 10 to the power minus 6 per degree Celsius. What are the things required to be calculated? We have to find out thermal stress in two cases. First, when the supports do not yield. Okay? So let us see here. First, change in temperature we will calculate. T is equal to 150 minus 50 is equal to 100 degrees Celsius. Okay? Now, let us see the first case when the supports do not yield. This is the simple case. The supports do not change their position, therefore delta is 0. So complete natural deformation is prevented. Therefore, here we can say thermal stress sigma T is equal to alpha into T into E, which is equal to alpha is 12 into 10 to the power minus 6, T is 100 and E is 2.1 into 10 to the power 5. If you calculate this on scientific calculator, you will find that the answer is 252 Newton per mm square. As there is fall in temperature, the nature of thermal stress will be compressive. Okay? So this is the first answer. Now let us go for the second answer. That is support yields. Supports yield by an amount 10 mm. Means supports get displaced by 10 mm. Okay. Now, in this case, delta is equal to 10 m. Means out of free or natural deformation, 10 mm deformation is not prevented. Okay? Now in this case, we know that what is thermal stress? Thermal stress is deformation prevented, that is alpha into T into L minus delta upon original length. This has become strain multiplied by modulus of elasticity, that is E. Okay? So if you substitute these things, what we get, let us see. What is alpha TL? 12 into 10 raised to minus 6. T is 100. Okay? 10 meter means 10,000 mm. This is alpha TL minus delta is 10 upon length is 10,000. 10 meter means 10,000 mm into value of E. Okay? So we will again simplify this. 10 raised to 6, 4 and 2. 10 raised to 6 will get cancelled. So this is 12 minus 10. 12 minus 10 into E is 2.1 into 10 raised to 5. This is value of E divided by 10,000 means 10 raised to 4. So if you simplify this, this will come out to be 42 Newton per mm square. No doubt, as it is fall in temperature, the nature will be tensile. Here also it is fall in temperature, so nature is tensile. Please correct it. Okay? So this is the answer of second part. So in this manner, we have calculated the thermal stress when the supports do not yield and the thermal stress when the supports yield by 10 mm. Do you understand this? Let us go for the last problem. A wire 1 meter long is heated to some temperature and then clamped between two supports. When it cools down to 40 degrees Celsius, it attains a stress of 100 Newton per mm square. Find the initial temperature of the wire before clamping. E is given, alpha is given. Okay? So let us solve it. What are the things given that we will first list out? Length of the wire is given 1 meter. It is heated to some temperature and then clamped. Let us say that it is heated to, let the wire is heated to T1 degree Celsius before clamping, means before fixing at the ends. Before clamping. Okay? Then T2 is given after clamping. Its temperature cools down, that is falls to 40 degree Celsius. When the temperature falls to 40 degree Celsius, the tensile stress in the wire is given, that is sigma T, that is 100 Newton per mm square. We have to find out the initial temperature of the wire before clamping, means we have to find out the value of T1. We are given E as 210 GPa, means what? 2.1 into 10 raised to 5 MPa, that is Newton per mm square, and value of alpha is also given, that is 12 into 10 to the power minus 6 per degree Celsius. Now this is a good example. First, that particular wire is heated. So what is the change in temperature, that we will first find out. The change in temperature, it falls down, so it will be T1 minus T2. That is T1 minus 40. Okay? Now it is very simple. We know that the thermal stress induced is equal to alpha into T into E. Let us put out the values. Sigma T is known here, 100 Newton per mm square. Alpha is 12 into 10 to the power minus 6 per degree Celsius. T here we will write as T1 minus 40, and E is 2.1 into 10 raised to 5. Okay? So, if you solve this using calculator, you will find the value of T1 is equal to 79.68 degrees Celsius. Means first the wire is heated to 79.68 degrees, then it is clamped, and then its temperature is cooled to 40 degrees Celsius, and the stress induced is 100 Newton per mm square. So in this manner, we have calculated the value of T1 and the example is complete. Such type of example will be asked in the examination for 4 marks. Okay? So in these 2 videos, this video and previous video, we have seen what is the meaning of thermal stresses or temperature stresses, what are the expressions, and then we have solved 5 different problems which will be very helpful to you while studying at the examination. So with this we finish this part of temperature stresses. Thank you.